Welcome back. Let's take a look at activity 9G. Now, this is where we're going to be looking at making sense of expressions and equations, really, of different situations that are happening, different word problems and word scenarios. So let's take a quick look first. There are, in the first section, question 1A and B, we have a situation where we have sand in a pile and some of it is removed, some more of it is removed or added, and then we need to know the total amount of sand in the pile. Now, we need to make sure that as we're reading the problem, which contains fractions, we know what those fractions represent. So we need to make sense of what the whole is for that fraction. And we've done this before with other examples where we were making sense of fractions. So for example, there are X tons of sand in a pile initially. So we're starting off with X tons of sand. Then a quarter of the sand in the pile is removed. Quarter of the sand in the pile is removed from the pile. And after that, another 2/3 of a ton of sand is dumped onto the pile, right? Two equivalent expressions in terms of X. Okay, so we have something, right? Then we're going to remove, right, something, and then we're going to add something back, and we're looking for the total sand that's in the pile. So we're starting with the X tons. Okay, so there's X tons of sand. And then the quarter of that sand is removed. So the fact that it's removed, it is going to mean that we're subtracting, our change is negative here. And we're going to subtract a quarter of the sand in the pile, which is started off with X, right? X tons. So we need to subtract a quarter of X. And after that, another 2/3 of a ton of sand was dumped onto the pile. So does it have anything to do with how much sand was there at the beginning? It doesn't. So it has nothing to do with X. It's just 2/3 of a ton. It's the same unit as for the X. And what we're looking at is, right, the expression for the amount of sand that is in the pile now. So there's one. Now another expression could be, well, if we have some sand and we're going to get rid of a quarter of it, couldn't we write 3/4 of sand, right, in the pile that of the initial sand is left, and then plus 2/3, right? That could be either one of those two. All right, let's take a look at number 2B. There are X tons of sand in the pile, again, tons of sand. 2/3 of a ton of sand is dumped onto the pile, and after that, a quarter of the sand in the new large pile is removed. Okay, right, the two equivalent equations. So we have X sand initially. Then 2/3 of a ton of sand is dumped onto the pile. So we're placing or adding, it's an add to situation. And after that, a quarter of the sand in the new larger, so this is the larger pile, right, is removed. So we need to remove 1/4 of that sand that was in the new large pile. Okay, so that's going to be our total number of sand in the pile now. Another way we could do it is could say, well, when we're removing a quarter of something, we're left with 3/4 of the new large pile. All right. That certainly could be another way. So what are in your expressions A and B, are they equivalent or not? And how can you tell? So I'd like you to take a look at the expressions. Is the expression for the first example the same as the expression for the second second problem? Try to make sense of it. Try to think about it from the point of view of the problem as well. Maybe draw it. If that helps. All right. So now, for question 2, we're asked to describe a situation, right? Now let's make sure that that we specifically express what X means. Specifically say what X means. So let's keep it at tons of sand. Okay. So we'll start with tons of sand. Let's see if we have an actual scenario we can come up with. So let's say we're going to start with X tons of sand, right? So that's where X tons of sand. And then we're going to remove a quarter X. So what is that going to be? We're going to remove a quarter of the pile, right? Okay, because that pile was with X tons. And then we're going to add 30. Add 30 tons of sand, right? And the question is, what's left is 150 tons. Okay, right? So that's what we have. Now in the second situation, we have X tons of sand still. Then we're subtracting a quarter, and then we're adding 30. So if we're going to look at this, so we still have X tons of sand at start. Now, what are we going to remove? We're not going to remove the quarter of a pile. We're just removing a quarter of a ton. Right? And then we're going to add 30 tons of sand. And what's left is 150 tons. So I'm going to leave C for you to think about. And let's do D together. Okay. So at some point we have a minus 60, X minus 60. Then we have 2/3 of that. And then we're adding 20, and the whole thing equals 80. All right. So let's start with X tons of sand at start. We're going to subtract 60, right? The minus 60. So we're going to remove 60 tons. Then, how do we get this 2/3 of this new pile? So then, remove, right? We could remove 1/3 of the remaining sand. So that would leave us with 2/3. Then add 20 tons of sand, and what's left is 80 tons. I hope this makes sense a little bit, that what you can always talk about creating some kind of an expression or an equation from your word problem, but you can always, given an expression or equation, create a word problem that makes sense. And that's something that's really important for us as teachers, but also for students to do, to really show our understanding of modeling real world situations with algebraic expressions and equations.